Okay, Algebra 2, please go to 624 for me. Go ahead and pause the video after you hear these instructions and read for me. I have a couple of paragraphs and then a small key concept chart at the bottom. It should look relatively familiar. But go ahead and read those for me, and I'll see you here in a second. Okay, you guys. Hopefully you just read about this new figure, which is known as a hyperbola. Okay, it's not a hyperbola. I think that's a pretty common mistake, but it's a hyperbola. All right, hyperbola. So the PER is pronounced like maybe a cat would be meowing. PUR, purr. All right, so hyperbola. Now there's a lot of stuff going on here, and we're going to get more into that tomorrow. Today we're going to deal with an equation that the center is at 0. Now I know this is kind of funny. Okay, so I'm going to get a real small. There we go. This will work. I want to kind of explain what they mean by center here. Okay, so this is very similar, and you should have noticed that that there were some similarities maybe between this equation and the equation of the ellipse, right? And if you look, right, and I'm going to try to find that page for you. If you look, you can find the equation of the ellipse at 616. Okay, so they're almost the same as these formulas over here. They're almost the same. The only difference is the ellipse has a plus sign, where the hyperbolas have a minus sign. Okay, so they're almost the exact same. We're just flipping them. So what it means is, remember, an ellipse is like an oval, right? Okay, so a hyperbola, since that minus is changed from the addition sign, instead of, like this side and this side going together and meeting, right? And then when they meet, they form the ellipse. The sides are turned away from each other, and so they look like this. All right, and then there are some asymptotes and things like that in there as well. All right, but I just want to make sure you understood what it means by the center. So if we had the center of the ellipse, remember it's like here, 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 here. So there's still a center of the hyperbola. It's just usually not marked. Okay, so that's what it means. And the center is obviously HK. Okay, the foci will be different tomorrow because we won't be at the well, maybe it'll be different in a couple of days, but they won't be at 0, 0 anymore. The center won't be, so the foci will move, but all of these things will stay the same for us. So let's go ahead and look at example 1 on page 625. It says, write an equation for the hyperbola shown in the graph. So I've already told you that our center is at 0, 0. However, if you don't believe me, look at the vertices, right? So I got negative 4, 0, and 4, 0. And just find the middle point between them. Find the midpoint between those 2 points. And it should be 0, 0. If you use the midpoint formula, it'll give you 0, 0. Or if you just count, right, from negative 4, 0 over to 4, 0, it should be 8 spots. So half of 8 is 4. And if you go 4 from either of those vertices, you'll end up at 0, 0. Okay, so we know that when we plug 0, 0 in, it's going to cancel the h and the k. Okay? Secondly, looking at this hyperbola, hopefully you can tell that it's opening left and right, which makes it a horizontal hyperbola, which means we will use this top formula. Right? If it was vertical, it would be down here. We're using horizontal. We want this top one. And we know that the h and k are 0, right? We're going to plug a 0 in there. So x minus h is 0. So I'm going to start off with an x squared over minus a y squared over, and it equals 1, right? We already know those things. And we know those because it's centered at 0, 0. The next thing we need to do is we need to find a squared and b squared, which are down here. And to do that, we need to first find c by looking at the foci points, okay? Looking at the foci. So if you look at those points, I believe the foci, the point, and we're using this one, right? The foci are, it looks like it's negative 5, 0, and then the other one is 5, 0, right? It should be this one because it is horizontal. So these are the foci points. Excuse me. And if you remember, do you see how it's plus or minus c? So the c value is, it's 5, right? Plus 5 or minus 5. So c is equal to 5. All right, so we use the foci to find C, and then we have a relationship formula between A, B, and C, and this one should look very familiar. It's this. Yeah, that's Pythagorean theorem. You guys got it. Last chapter, again with the ellipse, it was very similar, but it was like a subtraction. This is Pythagorean theorem. A squared plus B squared equals C squared. So what we will do is we need to go ahead and plug in everything we can, but right now we only have C, right? So what we need to do is we need to be able to find either A or B. Okay, so that's what I'm going to show you how to do. All right, so if you look over at this right here, okay, at the transverse and the conjugate, that's how you pronounce those words, the transverse and the conjugate axis, they are talking about the distances between the hyperbolae, which are similar to the major and minor axis of an ellipse. So I'm going to real quick draw our figure up here just so everyone can see what it looks like. Okay, so this is what our problem looks like, right? And our foci is like here and here. Okay, so the transverse axis is going from this vertex all the way to this vertex. That's the transverse axis. Okay, the conjugate axis is kind of running this way, but there's nothing up there. Okay, so like this would be like the transverse. So we're going to deal with the I think I got my words tied there. Sorry. This is the transverse. The conjugate would be running this way. Okay, so the transverse is the long one, and it's equal to 2a. Well, we already know how far this is. First off, we could use the distance formula, right? But I think we counted earlier. From -4, this was -4, 0, and this was 4, 0. If we count that distance, it should be 8, right? The length between -4, 0, and 4, 0 is 8. You can also use distance formula to find that if you don't feel comfortable, which we will use a little bit later, okay? So this is 8, so we're going to say 2a is equal to 8. Remember, the transverse axis is 8, and it's equal to 2a. So obviously a equals 4, right? All right, so now that we have a and we have c, we can use it to find b. So let's go to our Pythagorean theorem. A squared is 16, right? 4 squared is 16, plus we don't know what b squared is, equals 5 squared is 25. When we subtract, we'll get b squared equals 9. We square root b, obviously b is 3. Okay, so similar to the ellipse, right? The transverse axis will always be larger than the conjugate axis. You can see that with a and b here, 4 and 3. But to finish our problem, we go back to our equation up top. Whoops, wasn't very good. And we're going to throw in a squared and b squared, right? So a squared, a was 4, so 4 squared is 16, minus b squared is 3, so this is a 9. So it looks like our answer here, guys, is x squared over 16 minus y squared over 9 equals 1. All right, a couple things I want to point out. It's going to equal 1. All right. 2, these numbers are the squared versions. Don't forget you have to square those. And 3, the reason that there's not any numbers on top, right, is because it's centered as 0, 0. All right. Remember, if it was vertical, we would use this formula. But since we're dealing with the center at 0, 0, it would just have an x and a y up top. Okay, guys, that's all I have for you today. I would like you to try 2 problems for me. Go to page 628. I want you to try numbers 1 and 11. If you have any questions, you know the drill. Go ahead and post those things in the comments. I will try to help you out. Good luck.